guest, Dr. Waleed Ejaz from Thomson Rivers University, Canada. My dear friends, Sharda University is a leading educational institution, a venture of renowned Sharda Group of institutions. The university is approved by UGC and feels pride in being the only multidisciplinary campus in the NCR, spread over 63 acres, lush green campus equipped with world-class facilities. University offers around 216 different courses at undergraduate and postgraduate levels, including PhD in various domains. We have students from over 85 plus countries other than India and has thus become a melting pot of diverse cultures, backgrounds, and ethnicities. This is the last day of this international FDP, which is themed on recent advances in computer science and allied domains. And we are really very happy to see the feedback submitted by the participants after attending the sessions in the last 4 days. I now take this opportunity to introduce our guest and speaker to the audience, who is none other than Dr. Waleed Ejaz. Dr. Waleed Ejaz is an assistant professor in the Department of Applied Science and Engineering at Thomson Rivers University, Canada. He is also the founding director of Next Generation Wireless Networks Research Laboratory. Previously, he held academic and research positions at Ryerson University, Carleton University, and Queen's University in Canada. He received his PhD degree in Information and Communication Engineering from Sejong University, Republic of Korea in 2014. He has co-authored over 90 papers in prestigious journals and conferences of repute. He has also published 3 books. His current research interests include Internet of Things, energy harvesting, 5G and beyond networks, and mobile as computing. He is an associate editor of the IEEE Communications magazine, IEEE Canadian Journal of Electrical and Computer Engineering, and the IEEE Access. Dr. Ejaz completed certificate courses on teaching and learning in higher education from the Cheng School at Ryerson University. He is a registered professional engineer in the province of British Columbia, Canada. Dr. Ejaz is a senior member of IEEE, member of ACM, and ACM Distinguished Speaker. Today, he is going to share his views on resource management for IoT in future wireless technology. With this, may I now request Dr. Ejaz to kindly take over and address the audience. Dr. Ejaz. उनको अनम्यूट करो, वो म्यूट है.
Thank you very much, Dr. Arun, for kind introduction, and good morning, everyone. Although it's the night time here in Canada, it's 10:30 p.m. Here in Canada. So, okay, so let's move on to the topic. Once again, my topic of presentation today is resource management for massive connectivity. Massive connectivity means IoT in future wireless networks. As Dr. Arun said, that I'm senior member of IEEE. I'm working as an assistant professor in Thomson Rivers University, and also I'm ACM Distinguished Speaker. So with regard to IoT, recently we published, actually last year we published this book on Internet of Things for smart cities, technologies, big data, and security. So we tried to cover all the aspects of IoT in one book. It's a Springer brief book. So in one small set, we tried to cover everything. I will not go into the details, as Dr. Arun already mentioned all these details. Okay, so the outline of today's talk will be, I divided into 3 parts. First one is massive connectivity, what I mean by massive connectivity, what I mean by IoT, and what are the challenges. Then I will share some of my recent research progress and some most significant contributions we did here. And then as a researcher, how we look at these to address these challenges in a long term and in short term. How I look that what should be doing. When I say long term means how we will be looking at in next 20 years about these challenges, how we will be tackling these challenges in next 20 years. And when I talk about short term, that means what should we do in next 5 years to address challenges related to massive connectivity. Okay, so moving on the first part, I am assuming while talking about this thing is that you have very basic knowledge what Internet of Things are. So it is basically a brief introduction of IoT technology. So when we say IoT, previously the current internet which we are using, we can call it as Internet of People, not Internet of Things. Why I am calling Internet of People? Because people are connected with each other. For example, even if we are using social media, for example, Facebook, WhatsApp, or any other social media or any website, ultimately people are talking with other people, right? So we cannot say that things are connected with each other right now. So what we call Internet of Things is intelligent connectivity of things which is beyond people, in addition to people. So what these things are, things can be everything and anything. Let's take an example of this city, where we can see that we have transportation system, parking management system, we have power distribution, we have housing here. So if we go within one house, and let's say we can see there are many appliances here. We can see heating and cooling control. They can be smart, IoT based, smart meter and display systems, smart appliances. Let's take an example of simple refrigerator. So if we take an example of refrigerator, the point is, if we want to make it a smart refrigerator, what we need to do? First thing, we need to equip it with some sensors which can measure something inside. Maybe it can be camera sensors, it can be a weight sensor. For example, we can deploy a weight sensor in the butter tray. If the weight is less than this, that means we need to order the butter. In addition to that, we need some computation capability where we can compute data coming from sensors, and then communication capability. That means we can communicate that data, process data to someone. So for example, in future, how we will be looking at smart refrigerators, let's say if I have a weight sensor in my refrigerator, and I would say that it's a butter tray. If butter weight is less than threshold, what my refrigerator will do, it will automatically place an order online. Okay, deliver my butter for this home. What is available in the market right now, recently Samsung, LG, and these big brands, they launched many different smart type of refrigerators which can be connected with their other appliances. For example, which can be connected with their washer, dryer, and several other appliances. But the key limitation is Samsung devices can only work with the Samsung devices. It's not possible that Samsung devices can connect with LG devices, which really a big limitation from user point of view, because user is restricted to use only one type of brand for all everything. So some questions are coming. Okay. Anyway.
Not yet, sir.
Okay.
Not yet. We will take question answers at the last one.
Okay. So this seems to be one challenge, that what we want is we want these devices to be interoperable. So I will talk about this later as well. Why it's not moving? Okay. So there are basically, as I said, there are three main components of IoT. One is we should have some type of sensors. Now, these sensors can be in physical space and can be in cyberspace. Not necessarily we are talking about temperature sensor or GPS sensor. It can be data can come from WhatsApp, Facebook, Twitter, and from any cyberspace as well. So what happens is this result in unprecedented amounts of data. That means we have a huge amount of data to handle. Now, this is one of the challenges, that how to handle a large amount of data. Now, moving forward, as I said, that after sensing, we must have something to compute it. And after computation, what we want is we want to communicate it. Now, depending on the type of system, for example, if we are talking about smart homes, we do not need long range communication capability. So in that case, we may be fine with the Zigbee, Bluetooth, or even Wi-Fi technology for connectivity. In some cases, for example, in the case of smart metering, where we need to transmit a small amount of data to a long distance, in that case, we may prefer LoRa technology, Sigfox technology, because they are low power and long range technologies. For high power and long range technologies, we have LTE, that means 4G, 5G, and now people started talking about 6G as well. Now, the key difference between LoRa and 5G is basically cellular technology is inherently designed for broadband communication, for data-hungry applications. It is not designed for a small amount of data transmission. However, in some cases, as I mentioned before, in the case of smart metering, when we have a small amount of data to transmit, in that case, we will be wasting most of the packet space in the case if we start using 5G technology or 4G technology. So in that case, maybe LoRa or Sigfox are more appropriate. So depending on the type of application, we can choose which technology is appropriate, right? Another challenge we are facing, or we need to tackle with is, for example, if some device is using Bluetooth technology and another device is using Zigbee technology or cellular technology, how they can communicate with each other. Systems should be interoperable. They should, regardless of what technology anyone is using, they should be able to talk with each other. So this is one of another challenge we are facing. Then what to do with this data? I mean, once we have all this data from cyberspace, from physical space, what to do? We communicated it to the data center. Now what to do? Now we can analyze data. So data can be analyzed from at different levels. For example, it can be descriptive analysis. What happened? In a situation, we need to determine what happened. That incident has already happened, and we just describing through the data collection, the collected data. Then the second type is diagnostic analytics, which is to analyze why it happened. So this is a good example is the current situation of COVID-19, that if we have a lot of data available about patients or incidents from where it is originated. So what happened, why it happened, how many people are affected, why it happened. And then if we go one step up, predictive analytics is that what will happen in the future. We can predict based on the data that, for example, now people are predicting that, okay, in next month, there will be this much cases for the COVID-19. And then a further step forward is perspective analytics, that what actions to take in order to mitigate it. That's the most important thing. If you notice, I make this arrow going upwards. What does that mean? If we are moving from descriptive analytics to perspective analytics, complexity is getting high. We need to spend more computational resources to do the perspective analysis as compared to descriptive analytics. Now, IoT has several different applications. People are talking about smart housing, intelligent buildings, energy savings, and applications are endless. For example, one can look at other things, smart waste, smart green infrastructure, and many more applications can be there. I will not go into the details of these. However, the thing is, this has basically three main implications from the government point of view. For example, one is, okay, I will talk about smart cities later. Let's talk about three major benefits what we can achieve from IoT applications, which are established facts. So for example, in terms of cost saving, the forward-looking governments, they are already deploying IoT technology. For example, in Finland, they used sensors in the garbage cans, which can send them signal when to pick up the garbage. For example, here in Canada, they have 1 or 2 days, the city management has 1 or 2 dedicated days planned to pick up the garbage. Either it is full or not. So depending on the time of the year, sometimes it may get full very quickly. Sometimes in the holidays time, people are traveling, it may not get full. So what they observed in the Finland is it resulted in 40% savings in waste collection. So which is a huge saving. In terms of new revenues, in US, New York City, what they did is it's a very simple idea which every country can do. They displayed this interactive smart screens in the whole city. So based on the citywide sensing, communication, and response network, they provide some information to the citizens as well as they generate revenues from advertisement, right? So very simple idea. They are displaying temperature information, humidity information, when you are expecting rain, where the traffic is blocked or not. For example, in Canada, in winter, as you know, winter is very harsh here. So if you go on the highways where in summer that speed limit is 120, in winter, depending on the weather, it can be 60, it can be 80, it can be 100, or it can be 120. So basically, if the system is working automatically with the help of sensors, it can communicate with the people on the road. Then citizens, benefits for the citizens. In France, nice city, they nowadays many cities or many countries are using this smart parking systems. So they alert drivers about the open spaces. So with the potential to reduce the traffic congestion by 30%, especially in the big cities, I'm sure in India, Bangalore, New Delhi, and other cities, and also here in Toronto, Vancouver, traffic congestion is a big problem. Sometimes if you go into the downtown, you may spend half an hour, 1 hour just to find a parking spot, right? So what you can do is with the IoT technology, you can book a parking spot in advance, or your system is telling you that where the parking is available, and then you can book. And this not only generates more revenue, it also reduces CO2 emission. So in nutshell, we just looked at 3 types of benefits: cost savings, new revenue, and citizen benefits. There are plenty of other benefits. Now, for example, in terms of smart cities, when we talk about smart city, what does it mean, smart cities? Now, what is happening in the traditional cities, the government or city government is providing is holding basically infrastructure, and why they are holding infrastructure to provide services. For example, city governments, they have city government or provincial governments, they have this energy companies. For example, we have here BC Hydro, provincial level BC Hydro company. They have their infrastructure and they are providing services to the citizens or customers or residents. Now, what we want to do is, if we just add one more layer in between the services and infrastructure, that is data layer. Data layer comes from IoT because data will be collected through sensors. So in that case, what will happen is this IoT layer in between the services and infrastructure, it will provide smart infrastructure management. For example, when to update infrastructure, when to do service, when to do maintenance of the infrastructure, this type of information. At the same time, what it can do is, it can provide services, sorry, I moved in the reverse order. At the same time, it can offer smart services to the citizens. For example, in the case of BC Hydro, British Columbia Hydro Company, as a customer, I can see that how much energy I consumed in one day. Not only that, how much energy I consumed at what times. At 6 a.m., how much was the energy consumption, how much was the energy consumption at 7 a.m. and throughout the day I can see my pattern. So this really helps me to find, okay, for example, in the peak hours, I should not turn on my washer and dryer things, this stuff. Also, at the same time, what BC Hydro started doing recently, they usually have 1 year challenge. They give customers 1 year and they say, if you reduce your energy consumption by 20% in this year as compared to your last year, what we will do is we will give you rebate. We will give you $100 or $200 things, right? So just to give an incentive to customers, at the same time trying to manage energy efficiently. And there can be many other examples in the case of transportation, in the case of energy, and there can be several other examples in the smart cities. Now, this results with the data layer for consulting services. They say that IoT could generate $4.6 trillion in value for global public sector by 2022, just like 2 years from now, through cost savings, productivity gains, new revenues, and improved citizen experiences. So that means there is a huge potential of this technology. Now, one of the things I talked about while giving example of refrigerator, that what is happening right now with IoT, for example, if some company is developing building solutions, smart building solutions, so they have their existing infrastructure, they have dedicated devices for smart building. Similarly, energy company, they have existing infrastructure, dedicated devices, security. However, they cannot talk to each other. They are current IoT market is highly fragmented with small vendor specific applications. Now, I would say in recent years, it's not small vendor. For example, right now, Samsung is offering services, as I said, that refrigerator, washer, dryer, and everything is connected kind of thing. But what is happening? Everyone is reinventing the wheel. After Samsung, small companies will reinvent same type of services they will provide. So what we need to do is we need to make an end-to-end platform which have common services capabilities layer, right? And that has converged ICT infrastructure and M2M or IoT devices. M2M is machine-to-machine devices. So what is the benefit of this is, what we want to achieve is, we want to heterogeneous applications. That means different applications and different devices. Let me give you an example of healthcare system. So in the current healthcare system, for example, for stress disorder, healthcare providers need to collect data about patients, right? What they will do is they will measure maybe heart rate, blood pressure, sleeping profile to see how much stress and why there is stress in this person. However, we believe that this is very important to see the correlation of these things with the living condition of that person that can be achieved through smart homes, with the working conditions of that person, smart enterprises, with the pollution and noise in the city, smart city, and the condition of public transportation system and their effect on individuals. So my point is, you should not consider only one specific set of parameters. However, you need to find correlation with other parameters, other things as well, in order to correctly treat a person. So in summary, for IoT, first is we have exponential increase in connected devices and data generated. So that means we have huge amount of data. Now, next is we want this data to be communicated, to be transmitted. Sometimes, depending on the applications, data can be transmitted in real time as well. So that means communication capabilities should be very strong. And after that, when we collect data, we want to analyze this data. So thanks to the rapid development in the field of artificial intelligence and machine learning, now we can analyze and visualize data in a very efficient way. So building on this, what I mean is, in my area of research is wireless network. So I'm more focused on this part. I'm not expert in analytics part, but I'm more I have expertise in this part, communication part, and to some extent sensors management as well. So future wireless networks beyond 5G and 6G, they are expected to provide unlimited connectivity to a growing number of heterogeneous devices. So this is the target. We want to provide connectivity to heterogeneous devices and a large, massive number of heterogeneous devices. So that's why in the title I had massive connectivity, that we need to provide massive connectivity. So as I mentioned before, in this book, we try to cover all these aspects from sensors to data analytics part. So overall, if I talk about challenges of IoT, scalability of IoT is one of the key challenges. Quality of service. Now, quality of service is very important, especially as most of you guys are from computer science background. So quality of service previously, when we talk about cellular technology, most of the users, they are concerned only about data rate. We want very good speed, right? We want more bandwidth. However, in IoT applications, I mean, some devices may need to transmit only a small amount of data, right? So they may not be data hungry applications. Similarly, from the spectral resources, now when we say we have massive number of devices, so when they are communicating wirelessly, they are using some type of frequency. Now, frequency is a natural resource. You have a limited number of frequencies available to communicate on. So how to manage that frequency efficiently, that's another challenge. Now, in some applications, actually in many applications of IoT, your devices are energy constrained. They are battery operated devices. So we want to manage energy resources efficiently. Then interoperability, as I given an example before, that systems should be interoperable. Samsung refrigerator should be able to work with LG dryer and washer and other appliances. Standardization, this is one of the key issues. Who will standardize the protocols? Then security and privacy, this is, maybe you guys at the end of my talk will talk about this as well, that this is the key challenge. Wherever I go, this is the hottest topic, that how you will ensure security and privacy, right? So this is the area where you need to be focused on, that where a lot of research is needed. Then when I say global reach, this is again connected with my research area. So when I say global reach, it means you should be able to provide connectivity anywhere and anytime, in the remote areas, in the regional areas. Even in Canada, there are some highways. I don't have that map right now with me, but there are some highways where there is no coverage of cellular network because of the geographically, Canada is a very big country. So where there is no population, there is no connectivity. So if, for example, last year there was an accident of school bus there in that region. So that can be a very challenging sometimes. So how you can provide connectivity in the remote and regional areas, that also needs to be investigated. So with this, with these challenges, my research focus is more on resource management schemes, where we say that we need effective resource management schemes in future wireless networks, mainly because of three main challenges. One is there are massive resource constrained devices. As I said, that most of the IoT devices are resource constrained. Sometimes energy is a constraint. Then they have a diverse quality of service requirements. Some applications may need high data rate, high reliability, real time. Some may need low data rate but high reliability in real time. So diverse range of quality of service requirements are there. And a high density of heterogeneous devices. There are different types of devices there. Now, although there are many people working in this area, still I believe that we need to develop some sophisticated approaches for sustainable networks. What I mean by sustainable network mean, actually, let's make this word self-sustainable network. Self-sustainable network mean a network which operate on its own. Maybe energy harvesting, in terms of energy, we need to charge the devices automatically. We don't want to change the batteries. Network should be operated on their own. So therefore, we need novel resource management schemes with constraints on connectivity, quality of service requirements, coverage, which should be able to cope up with the challenges of massive heterogeneous devices. So this is basically the main emphasis of my research program, which I'm running here at TRU, Thompson Rivers University. This is the main emphasis of resource management while considering these constraints and providing connectivity and dealing with the challenges of massive heterogeneous devices. So with this, I'm done with my first part. We have, Dr. Arun, we have both options. We can take questions from the part one now, or we want to take questions at the end.
Yeah, thank you, sir. So if you want, I can take the questions. I will read the questions for you, sir. We have first question, which is from Imran Alam. What are the enhancements in 5G or 6G in respect of 4G?
What are the enhancement in 5G and 6G?
5G or 6G with respect to 4G.
Okay, so up to 4G, basically, when we started from 1G to 4G, There was only one challenge in front of us: provide broadband connectivity. If you see the pattern from 1G to 4G in each technology, the only focus was on the data rate, provide better data rate, more bandwidth. With the advent of this IoT technology, as I mentioned before, now we have a diverse range of quality of service requirements, right? So we are not only limited to only broadband applications. As I mentioned, for example, in the case of smart metering, we need only a small amount of data to be transmitted. So the problem is, if we do changes in the 4G network, which was inherently designed for broadband communication, not for small amount of data transmission, we will lose a lot of resources. So that's the reason why we need to move on to 5G, 6G. Another reason is, let me go to, okay, I think I will talk about this later as well. But another reason is we need to provide coverage to massive number of users. We need to provide connectivity to massive number of users. So one is to accommodate diverse range of quality of service requirements from users. Another one is provide connectivity to massive number of devices and manage your spectrum resources efficiently. And there are many more reasons we are moving from 5G and 6G.
Thank you so much, sir. And another question we have is, the participant is the use of IoT application in emergency rescue.
Emergency rescue.
Yeah.
So there are plenty. For example, in the case of disaster management, we did one project on this thing. That in the case of disaster management, what we can do is we can deploy sensors in the disaster area. And with the help of new technology, these days we are talking about UAV assisted networks, unmanned aerial vehicles network. So what we can do is we can collect data from there and do analysis. We can provide remote healthcare services to those people in the disaster affected areas. We can also, for example, we developed one application in the past, which was for industrial workers. So in most of the cases, when people working in industry, especially the labor workers and working in industry, they are not aware about the dangerous situations. So what we did is we developed a jacket and a helmet for industrial workers. When they go into a specific situation, if there is any dangerous situation occurs, it will notify them, okay, you need to evacuate from here, right? So that was the application we developed. I will talk about this more.
One more participant is interested in knowing the difference between normal IoT devices and heterogeneous IoT devices.
So when we say heterogeneous IoT devices, heterogeneous mean different types of IoT devices. So heterogeneous doesn't mean that a specific IoT devices. Heterogeneous, for example, we have one IoT device which has, let's say, temperature sensor, which has humidity sensor, and another type of IoT device which has GPS sensor, and different type of sensors are installed in that device. So when we call them together, we will say, okay, we have different types of IoT devices in this network. That means heterogeneous devices.
Yeah. Now I can say a very appreciation comment to you, sir. Great presentation, and the participant is interested in knowing that how will you explain the concept of a smart city to a layman, not to a technical guy. If the person in front of you is a layman, how we can explain the concept of smart city to that layman?
Okay. So for the layman, as I mentioned in my slide, what we can tell them, Recently, I was a presenter somewhere where there were non-technical people, and when I presented the concept of go back on the smart city, this one. So I told them we deploy more sensors. This can help you manage infrastructure and provide better services to the